In 2016, after receiving all this data containing more than 2 billion records of lab tests in Ontario, Sicence stepped into the cut. It's pronounced ICES. Thank God, while traveling to the south of the border, I no longer need to introduce myself as I'm Mahmoud and I work for ISIS. Believe me, not a good combination.
Yeah, because I remember getting my American passport. I was like, woohoo, gonna travel. Open it up and said, born in Iran. Oh, come on. That's not gonna help me get around. It's like having bad credit.
I was saying ICES stepped into the world of big data. Believe it or not, OLIS was big enough to come to us on a portable hard disk by an armored truck. Well, this is what I was expecting to see, but it was more like this. We discovered that some test results such as pathology and microbiology were in free-form text field. That means we should expect to see literally any form of information embedded in the test results, like phone numbers, addresses, or even names. It wasn't OLIS only. In an echocardiogram data, we found notes such as this one. Or in EMR data, we found even more strange notes like this. Soon we realized that we have to deal with more than 400 million records of test results alone because of this situation. We were in crisis until...
Look on the bright side, Dad. Did you know that the Chinese use the same word for crisis as they do for opportunity?
Yes, crisis-tunity. You're right.
So we decided to look at the bright side and build a tool. But how? What do you do when you don't know how to do something? You Google how to, right? No, we didn't. We did a little review on the identification of free text field, and a BMC paper from MIT took my attention. Interestingly enough, this is also a second result of a how-to Googling. Ishnan Matola and others had developed a pattern matching the identification algorithm. They developed an open source software in Perl which uses few dictionaries to identify PHI. It sounded very promising, but there was a problem. We didn't have Perl programmer. So I emailed my team to see if we had anyone with some experiences in Perl. The next morning, I received 3 replies.
Hi Mahmoud, I did use Perl programming long back. Not sure how much I can recollect. I have used...
Hi Mahmoud, I learned a little Perl stuff when I was in China long time ago.
Hi Mahmoud, I'm definitely not lightning fast with regular expressions, but I do have some experience. Please let me know if I can help.
We quickly formed a working group and scheduled few meetings to tackle this
crisis-tunity.
In few months, we developed a SAS-based macro. We later called it Mask.
The Mask.
Mask leverages hash objects to store our big dictionaries into the memory. It also uses Perl regular expression functions in SAS to scan sentences for special patterns. In ICES, we have the luxury of having access to a provincial registry called Registered Person Database. RPDB has all the demographic information on all Ontarians who have been ever issued an OHIP card. Almost everybody. Using RPDB, we created a dictionary of all unique names that have been ever appeared on OHIP cards. 1.4 million names. We also know how popular each name is in Ontario. The first few tests were disappointing. It was overmasking. We had too many false positives. Many common English words, which happened to be someone's name at some point, were masked. Using an open-source pocket-sized English dictionary, we were surprised to find more than 10,000 words being overlapped with our name dictionary. Using the English dictionary improved the output, but there was still too many false positives. In running Mask on a 40,000 records echocardiogram dataset, we discovered that LV, which happens to be a rare name in our dictionary, was masked 6,000 times. In this relatively small dataset, LV in this cardiovascular dataset was an abbreviation for left ventricle, and there was more, like Edwards, or Duke, or Jude. So we added more medical dictionaries to the Mask. To eliminate the amount of manual interventions, we are in early steps of a collaboration with University of Manchester to add an AI layer to the Mask. Azad Dehqan, Goran Nenadic, and others have developed a method based on rules, dictionaries, and data-driven machine learning for identifying PHI in UK's clinical narratives. We are aiming to empower Mask with their methods to build an open-source context-driven tool for the identification of free text field for Canadian clinical data. A Toronto-based startup company also has offered us their help. If this is your challenge too, why don't you join us?